Hello everyone. So today we are going to discuss about the remove method in our array list and by using a object. So yesterday we discussed about the add method by giving the value and the index, and the remove method by using index. And if you remember, in that removal there is a possibility if you give me a wrong index, there will be out of bound exception. But in this one, the one which we are going to discuss today, it's basically in every array list, if you go and you say okay dot remove, it will give you multiple overloaded functions, and one of them is you can give the object. So once you will give the object, in that case basically it's saying okay, if I found, I will remove and I will return you true, and in case if I don't found, I will return you false. So there will be no exception. The format is same. First we will review the code on a IDE, and then after that we will execute some use cases. Only one point. So today I have I kind of I have a conflict with the JDK implementation. When I saw first time, I feel, oh, why they implemented in this way, and then later I agree with the one implementation, but I don't agree with another implementation which I will share with you once I'm in the IDE code review. So yeah, it's an opinion. Maybe I don't understand why they did, but still I have a feeling they can reuse some code.
I mentioned with you, I have a different opinion when I read the code first time, but later after spending some time, I figure it out and I appreciate the JDK approach, and I also uh, learn something new. So I will share with you first my approach. So as you remember, yesterday we implemented the remove method, this one, okay, and that take the index and do some work to remove. And because I'm a big fan of reusability and the small functions, so in this case how I will implement, okay, we need a loop, then after we need to check at that index I found the object or not. So I will create two small methods, is null and found, is not null and found. So in case of is null and found, I'm checking, okay, if the given value by the client is null and that also available inside of our element data, it means we found at that specific index. And on the other side, if the object is not null, and I'm going to check, if not null, then I'm checking, okay, equivalent. So all objects have the equal method, and most of the time the extend every object is extended by the Java object class, so the equal method is there, so we are checking according to that, and if it works, it will give us the true. It means I will say okay, I found that. So mainly we found that index. Now once we found that index, now I can use my remove method which I already implemented. But there is one issue which I will again do refactor this little bit. Like for example, in this case, this range check is useless. It's a waste of CPU cycles, because we already found the index, and if we found that index, it means it's a valid index, so there is no need to check this. Then this one is again a waste, because I don't care about that object, I only want to remove that in the value on that index. So we need to do basically from here, start this and then copy this and then this work, and that is enough, and there is no need to remove. But if I reuse that method, it means I'm doing these three things which are useless. So I can do refactor this method, okay, the commonality is this code, so I can make this a small private method and I can use the same here and inside of my this. So that will be my approach, and now we can see their approach. So how they implement it, basically first they take null as a separate branch, and the object is a valid object. Valid means has a value as a different branch. So by doing this, they separated easily, okay. Then they are using the for loop, okay. So in this case of for loop, and this is a kind of a duplication of a for loop. Then after they are checking, in case of a null, if element data is null, it means they found the index, and in case of a equal, then again they found the index, but they are not reusing, which I really appreciate their approach. So they created a separate method, fast remove. What is fast remove? So if you see fast remove, what they are doing, okay, first they are not doing any check, the boundary check, because that doesn't make sense to do, we already found that. Then they are copying is the same thing how we did in a different object, and after that they are only doing the null and they are not returning anything. So if you compare like these lines with our yesterday implementation, so you will see these are the same. So this part is same, so they are saying this one is a fast remove. Okay, now as an application uh, developer, most of the time we don't care about these small things. Okay, if it's a extra if, or we are writing extra loop, it's okay because we don't have enough data. It may be 10 values or 20 values, so by doing an n square it's still again maybe maximum 100. But when we are writing for the SDK, then you never know who is going to use your SDK. So you should be very careful with the writing code. Code should be efficient, most efficient, but also readable and maintainable. It doesn't make sense to make a code efficient by start using bit operators and playing with the bits. It is okay if you need to do something for some specific critical area, but otherwise, yeah, don't, try your best, don't do extra if checks, extra loops, because you think okay, it's a small thing. Why I'm saying, if you do, then you have a different kind of a habit writing code. Then when you go into the problem solving, you can't understand that, because on daily basis you ignore that. And sometimes if you ever write a code for example for mobile apps for iOS or Android, you can easily measure how much CPU you are using your code. And once your code is using extra cycles, then it is going to use extra battery, because everything on a mobile device is run by the battery. And if you have a one loop, a for loop, and you are running every time that loop, and it's impacting the CPU cycles, and you know, okay, if you use the sliding window technique or a summation, so there is no need to write a for loop every time, only you can minus from the total sum and plus the new value, kind of like that. Then you can easily see your metrics on a dashboard or anywhere where you are implementing, how much you are going to save and how that is going to impact on your whole consumer base. If you have a 10 million users and you start saving, for example, for everyone 3 cycles, you will see the impact, the global impact, and you will feel better, like yes, you did something, you save a lot of electricity also. So I will say I totally agree with with this code, like managing null separately and the value. It's look more easier to read. Yeah, I can understand it's more bigger. Like they need to write extra lines of code, but still I feel, yeah, it's good. If you see my logic, it's pretty from the readability perspective. You need to read this and then go inside, then read this, then go inside, and I'm not sure from, like, yeah, it will create a one stack when this will be called, then this is also a stack call, then it will be back, then it's coming here. Otherwise every time one for loop, for example, if there is a 10 times, and if we need to run this also 10, so 20 times it is going to push and pop, push and pop, push and pop. But in this case, once they will figure it out, okay, it's null, then from the memory perspective they are not doing any extra stack, because they are checking everything inside. So yeah, here we can say, okay, that is the better approach. Now about the fast remove, yeah, this one is a good approach here, but I still kind of disagree with with their code. And like I think i I don't feel if they use the directly this, mm, here, and they remove this, it still look nice to me, and I don't feel anything bad I'm doing. Instead, I appreciate this code. So I'm not sure what is the reason, but that is my opinion. So okay, so yep.
I hope you enjoy the code review, and a different perspective, my perspective, how I implement, and in the end, the how they are using fast remove, and they have a duplicated code, and why I want to refactor their code, and the fast remove I will use in the yesterday's remove implementation and today's one. But it's okay. So today for the execution, I have these four use cases, and I decided, okay, I have a one array of size 5, so we can make that array. So basically it's an our array list, and inside of that array list we have 5 objects which are not int, they are integer objects, and today I'm not going to make these as an address. uh, I'm going directly with the values. So for example, 1, 2, 3, 4, 5. So yeah, please remember, just like we discussed yesterday, these are the addresses of those objects which are available somewhere in a heap. But I'm going with this today directly inside. So I hope you remember that. Okay, so first case is, I have a list dot remove and null. So as you remember, if I have this array, then this method is going to return me false, and the performance of this will be big O of n, because I have n values, size n, and I need to scan all loop. And for example, here I have null. Now in this case what will happen, I will found on index 4 null. So here what will happen, we will call our fast remove method, and in that case what I will say, okay, I will say, okay, please do copy from index plus 1 to index. So basically it will happen like this, and it will be only once, because I'm our algorithm is size minus index minus 1. Now this is copy, the last value I need to do null. So in that case it is going to be null. So the compile, like there is no more duplication. Now consider we have this value, this array, and now the client send us this remove with null. Now what will happen in this case? So we will form this null in the end, and in this case we have our again our same size minus index minus 1, which will give us the remove. So it's basically 5 minus 0, 1, 2, 3, 4 minus 1, which is equal to 0. And if you remember, in our code we have a check. So I think this is move. So if move is greater than 0, then do system dot copy, array copy. So in this case what will happen, it's it will come here, it needs to check. So it is again big O of n for a loop, but there is no copy due to this check. So still it's a big O of n. Okay, then in case of a second case, when I am going to say, okay, 1. So now we have an object 1. I jump in, I found, okay, at a first place. So now index 0, I will form the index 0, I will send that to the fast move remove index 0. What do you think, what will be the performance of this? So I found at a first index we are not scanning. It's kind of a best case of a loop, because it's a first place, but still once we will move inside, I will say, okay, now copy, do copy. So 2 will come here, 3 will come here, 5 will come here until this, and then after that we will put here null. So it will be like 2, 3, 5 and null, but it's still kind of a big of n, because under the hood system.copy will run and that needs, so this is not a best case. It means, okay, so I think that the best case will be always like the last one also, but in that case we will run again the big O of n. So the best case of this method, I think so, it's always big O of n, and the worst case is also big O of n, as per my understanding. Am I missing something? No, because if we found something here, then we need to copy all that in a new array, so it still big O of n. If I found the last object, then my first loop needs to run scan until end. Yeah, in the end I'm not going to create a new like in not new, in the same one, same array copy, it will be no, there is no copy, but still, so in both cases it's a big O of n. Okay, now what we can do, if I give a 10, in that case, yeah, I need to search big O of n. Not, there is no object which has a 10, so it will return false. Then if I say in between 5, so in that case what will happen, so first it need to scan until half of the loop, so index, and then after that it will go inside of a system.copy and it will move only one, or maybe there will be no, okay, we will see. So move is equal to size, currently our size is 3, and minus index minus 1, so 3 minus index, index is 2, 0 1 2 minus 1 is 3, is equal to 0. So it means there will be no system.copy call, because we have a condition, if move greater than 0 then do system copy, but we will do directly null here. In this case, still we need to run the loop until half. Okay, now there is a last case which I am going to create. So I have only one value, for example 1, and this is null. Now we can say this is a best case of this method. Why? I will do this. I will found at a first attempt, okay, this is on 0. I will go remove, fast remove, size is 1, minus index is 0, minus 1. So move is 0, so there is no copy, nothing, only I need to do two operations. One, I need to scan first time, it's a I, for I is equal to 0. So this is true one time, and then I need to do element data size, sorry, it will be minus size, because first we need to move at 0 and then null, and both are 1. So this will be the best case of our remove object method. So every time when you are going to use this method, try to remember all this analysis, so that will help you when you are in an interview and you are thinking from this perspective every day, because I know every developer is using array list or linked list, and we are using these methods: contain, add collection, remove all, clean. So try your best to ask these questions to yourself on daily basis, then there will be no, there is no need to prepare for these things. You are already ready every day, every time. So yeah, so I think today's topic is complete.